All right, guys. So this is lesson 13.3. So this is the third day of sequences, okay? So the first day was just like sequences in general. The second one, which was last time, was arithmetic. And today is geometric, okay? So you need to understand the difference between arithmetic and geometric. Arithmetic is when the same thing's added or subtracted every time. Geometric is when the same thing is multiplied every single time, okay? It's not divided, it's multiplied, okay? So if you look at the first sequence, 2 to 6 to 8, okay? Well, 2 times 3 is 6, 6 times 3 is 18. I said 8, I meant 18. And then 18 times 3 is 54. 54 times 3 is 162. 162 times 3 is 486, okay? So the ratio is 3. That's what it's called. So for arithmetic, it's the difference. For geometric, it's the ratio. Okay, so look what's happening here, guys. You go from a positive to a negative, and then from a negative to a positive. So the only way that's happening is if the ratio is a what, everybody? Negative, okay? Now what I want you to do is I want you to forget about the signs. I want you to just look at the numbers because we just figured out the signs, okay? So look, guys, from a 32 to a 16 and then 16 to an 8, what am I doing? Can you tell? Like, you're dividing by 2, right? So the next one would be a 4 and then a 2 and then a 1, but the signs are going to alternate, so that would be a negative and that would be a negative. But you can't say divide by 2, okay? So you're going to have to say dividing by 2 is the same thing as multiplying by, tell me. 1/2, yeah. So your R is a negative 1/2, okay? All right, so here's a pattern. We're going to come up with a formula, okay? By the time I'm done today, guys, you're going to have 5 formulas for sequences that you have to have memorized, and it's all on that formula sheet I gave you. Okay, so right here, guys, look. N is 1. Here, N is 2. Here, N is 3. Here, N is 4. And then we're going to have N equals 5, N equals 6, and this one right here is just going to be N equals N. Okay, so they all have an A. So I'm just going to put an A in front of all of them. They all have an R except for the first one. So I'm going to put an R there. And then we're going to figure out what it's supposed to be. So guys, look, if N is a 2, your R has an exponent of 1. 3 is a 2, 4 is a 3, 5 would be a, tell me everybody, 4, and then 5. And then this one would be, if N is 1, then there is no R. So what's it going to be? What's the exponent of the R going to be? Can you guys tell? It is N minus 1. Okay, good. So right here, A sub N equals A times R to the N minus 1. Okay, highlight it or put a box around it. And I want you to write specific term. So that's your formula when you're looking for a specific term of a geometric sequence. You guys know that A and A sub 1 stand for the first, both mean the same thing and they stand for the first term. And the R is what you're multiplying by. Don't say dividing, it's always what you're multiplying by. And this is called the common ratio. Okay? Okay, example 1. This sequence is geometric. Find the A and find the R. Okay? So let's go A sub 1, A sub 2, A sub 3. Let's list them out and kind of figure out what's going on. Okay? You guys, on A sub 1, N is 1. So that would just be 3 to the first, which is 3. For A sub 2, N is 2. So that would be 3 squared, which is 9. A sub 3, N is 3. So that's 3 to the third, which is 27. So one of the things that they want is your A, which is the same thing as the A sub 1, which is a 3. Okay? The other thing they need is the common ratio. So it's what we're multiplying by. So 3 times 3 is 9. 9 times 3 is 27. So your common ratio is a 3, and you're done. Okay? Example 2. Find the first 5 terms and the 15th term if A is 3 and the common ratio is 2. You guys, I know it's not arithmetic because they called it a ratio. If they said common difference, then I know it would be arithmetic. Okay? Okay, so let's go A sub 1, A sub 2, A sub 3, A sub 4, and A sub 5. okay? So the first term is a 3. And then, you guys, the common ratio is a 2, which means I'm multiplying by 2 every time, right? So 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, 24 times 2 is 48. Now, if I were you, if this were on my final, I'd go 3, 6, 12, 24, 48, and I'd write it like that, okay? That's all we have to do. Oh, they want the 15th term, actually. So let's go a sub n equals a times r to the n minus 1. So we're finding a sub 15 is the first term, which is a 3. The common ratio is a 2, raised to the 15 minus 1, which is 14. Okay? Grab your calculator and go 3 parenthesis 2, close it off, raise it to the 14th, hit enter, and the answer is 49,154, and we're done. Okay, find the 22nd term. This is what I was kind of saying last time, you guys. If this is how it shows up on your final, okay, then look what I would do. You have to know if it's arithmetic or geometric, because the formulas are totally different. Okay, so look right here. 9 subtract 6 is 3. Is 3 subtract 6 1? No. So then I know it's not arithmetic. I'm sure that you guys can tell that it's geometric just by looking at it, right? If the numbers are getting smaller, then you're going to be multiplying by a smaller kind of number. We're dividing by 3, right? 9 divided by 3 is 3. 3 divided by 3 is a 1. Dividing by 3 is the same thing as multiplying by what, everybody? 1/3 is correct, okay? So I know it's geometric. I think it would probably be pretty wise to write geometric. And they want a specific term, so I know my formula is a sub n equals a times r to the n minus 1. Okay? They want the 22nd, so a sub 22 is the first term, which is a 9, times the common ratio, which is 1/3, raised to the 22 minus 1, which is 21. Okay? Everybody look at how I've written that. That's wrong. Can you tell me what's wrong with that? Why do you need parentheses? Because it looks better? Like, why do you need it? Without it, it means the 1 is raised to the 21st, but not the 3rd. And it's the whole thing, like that. Okay? Okay, everybody go 9 parentheses, 1 divide 3, close it off, raise it to the 21st, hit enter, and I get this big, huge number. Do you get a big, huge number? Okay, so I know that's not going to happen, just so you guys know. Okay? It's too big. So basically what this is scientific notation. So look at what you get on your calculator screen. It's 8.6 times 10 to the negative 10th power. The number is it's actually so small. It's so small that it won't even like fit on the screen. So the calculator just puts it into scientific notation. Okay? Don't worry about it. You know, it's not going to end up like that. You'll get something like 0.00000. Basically, I'm just going to tell you. Let's write it down. Okay? We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 6. So 9 zeros and then an 8, 6. Okay? So what this means is take that decimal and go to the left 10 places, which would put you 9 zeros and then an 86. It's not going to happen. Don't worry. Okay, this one right here, finding the sum of a geometric sequence, basically you're just going to have to memorize it, okay? We're not going to go through and derive it or figure it out like we did the other one. We're just going to memorize it, okay? So A, you guys know, is the same thing as a sub 1, which means the first term. R, we already talked about. It's the common ratio, okay? And N is the number of terms that we are adding. So if it says find the first, the sum of the first 20 terms or whatever, then my n is going to be a 20. Okay? Find the sum of the first n terms of the sequence. Okay? Take your highlighter and highlight it, or take your pencil and box it, the words n terms. Okay? Then I want you to draw an arrow to it. This is now the 3rd time we've written this. Okay? If you see n terms, what do you know, guys? You're going to have an n in your answer. Yep, don't freak out when you have an n in your answer, because they didn't say like the first 10 terms or something like that. Okay, so everybody go S sub n. Now, if you wanted to, you can come over the sides and say, what's A, what's R, what's N? N is going to be an N, because they didn't tell me to find the first 15 terms or whatever. The common ratio is this number that's inside. Do you see this right here? This is your common ratio. So my R is 1/2, and the A is the first term. Well, guys, if N was a 1, then that'd be 1/2 to the first power, which is 1/2. Okay, let me do something really fast just to make sure we're okay. Everybody write this down for just a second. Go A sub 1, A sub 2, A sub 3. Okay, so let's just find a few terms, basically, is what I'm saying. So A sub 1 is going to be 1/2 to the first power, which is 1/2. A sub 2 is 1/2 in parentheses to the second power. That's going to be 1/4. A sub 3 is 1/2 to the third power, and that's 1/8. So I can see my first term is a 1/2. What do I multiply by 1/2 to get 1/4? That's 1/2. 1/4 times 1/2 is 1/8. So now I can see that the ratio is 1/2. Do you really have to do that? No. I just feel like I needed to offer you an explanation. Who says I'm good with that? Let me see. Okay, good. Okay, so let's find it. Okay, so the sum of the first n terms is the first term, which is 1/2. See the parenthesis? I'm actually going to make it a bracket just because sometimes it gets kind of complicated. And then it's going to be 1 minus the ratio, which I'm putting in parentheses. See how I put parentheses around my formula that you're memorized? Raising to the n power over 1 minus the ratio, which is 1/2. Okay, now that's not your answer. I'm going to show you what we're going to do next, and it is just a little bit confusing, so I want you to watch closely, okay? 1 minus 1/2. What is 1 minus 1/2? Tell me that. That's really 1/2, okay? Don't mark up your paper, but I'm just going to mark up mine. This is really 1/2, okay? Now that 1/2 is on the bottom of a fraction. If it's on the bottom, we're really dividing by 1/2. Who says I understand that? Okay. Dividing by 1/2 is the same thing as multiplying by, tell me everybody, 2/1, right? Flip it upside down. So now what I'm going to do is I'm going to take that thing that I'm multiplying by, and I'm going to put it right there. I'm going to multiply the front by that. So this guy I already took care of. I put it right there. 2/1 plus 1/2, that just goes away. So my final answer is 1 minus 1/2 in parentheses to the n power. So 1 minus 1/2 is 1/2. Take the 1/2 and flip it upside down, and it gets multiplied by the front, and then 2/1 times 1/2 just goes away. So you have 1 minus 1/2 to the nth power. Okay? Okay. Who says I got that? Let me see up high how we're doing. Okay, great. Find the sum of the first 6 terms. Okay? First of all, let's decide if it's arithmetic or geometric. Okay? 27 subtract 18 is 9. Is 9 subtract 18 3? No. So I know it's not arithmetic. And then I'm like, okay, well, they're getting smaller. So 27 divided by 3 is 9. 9 divided by 3 is a 3, so it totally works. But I can't say divided by 3. I have to say multiplied by what, everybody? A third. Okay? So your formula is S of n equals A sub n. Sorry. Yep, A. I'm going to do a parenthesis. 1 minus r to the n over 1 minus r. If you don't throw parentheses around it like this, it's okay. Just know that when you put the number in, you need to put parentheses around it. Okay? Okay, so the sum of the first 6 terms. Like I said before, if you want to, you can go A and R and N. So A is your first term, it's a 27. The ratio is what you're multiplying by, which is a third. And the n is the number of terms we're adding together, which is 6. So this is just going to be literally sticking this in our calculator. So the first term is a 27. Then I'm going to go bracket, just because it gets a little complicated. Then 1 minus, in parentheses, 1/3. Close it off. Raise it to the n, which is 6, over 1 minus 1/3. Okay, and everybody listen. We're going to put this whole thing in one even, just one big input into the calculator, there's two places that I need to put parentheses around. Can somebody tell me? The fraction. Where in the fraction though? The top, yep. So everybody add parentheses on your actual paper right there, okay? And then there's one more place I have to add parentheses. Somebody tell me. The bottom is correct. Good. Okay. Do me a favor and just look up right here. Okay. Just look for 2 seconds. If you watch me point, then it's going to make more sense. Look right here when you put it in. You're going to go just what you see. Literally, if you add those parentheses, you just put in what you see. Look. 27, parenthesis, parenthesis, 1 minus parenthesis, 1 divide 3, close parenthesis, raise it to the 6, close parenthesis, divide, parenthesis, 1 minus 1 divide 3, close it, enter. So you literally just follow the line, okay? Okay, let's do it now, okay? Everybody go 27, parenthesis, parenthesis, 1 minus parenthesis, 1 divide 3, close parenthesis, raise it to the 6th, close parenthesis, divided by parenthesis, 1 minus 1 divide 3, close it, enter, and I get 40.4 repeating, right? Okay, don't touch your calculator for me. Okay, now I have there's a cool little trick on your calculator that will help you with this. Everybody hit second, and then diagonally from the second is the PRB button. Hit that, and then hit enter. And when you do that, it converts that decimal into a fraction, bless you, which is 40 4/9. And that's it. Okay, question B. Find the sum of the first 10 terms of the sequence. Okay, so I can see that I'm multiplying by 2, multiplying by 2. Okay, so I know that this is geometric. Then I'm going to write my formula. S sub n equals a times 1 minus r to the n over 1 minus r. Okay, if you want to make a list, make a list. A and r and n. A is the first term, which is a 3. The ratio is a 2. The number of terms I'm adding is a 10. So this is easy. It's just literally a calculator problem. So the sum of the first 10 terms is the first term, which is a 3. I'm going to do a bracket. 1 minus 2 to the 10th power over 1 minus 2. I would literally, if I were you, I would add parentheses around the top and parentheses around the bottom. Okay, so go 3, parenthesis, parenthesis, 1 minus 2, raise it to the 10th, close parenthesis, divided by parenthesis, 1 minus 2, close it, hit enter, and I get 3069. Now, I did do something different on this. That's the correct answer. We're good. I did not put parentheses around the 2. Can anybody tell me why I didn't do that? I didn't need to. It wasn't a fraction. It wasn't a negative. Had I put parentheses, it would have been right here. Guys, look. Parenthesis, parenthesis. And it wouldn't have been wrong, and it also wouldn't have changed it. So maybe a good idea is to just always throw the parentheses around it. That way you never mess up. But, you know, whatever's fine. Okay, here we go. Find the summation of n equals 1 to n equals 6 of 12 times a negative 1/2 to the n minus 1. Okay, so they want a sum. Now, we could do this. Everybody go a sub 1, a sub 2, a sub 3. On a sub 1, n is a 1. So that's going to be a 12 times a negative 1/2 raised to the 1 minus 1, which is a 0. Now, I could put it in my calculator, but anything to the 0 power is a 1, and 1 times 12 is a 12. Okay, I'm going to do the next term. So 12 times negative 1/2 to the 2 minus 1 is a 1. Okay, if I put that on my calculator, guys, I go 12 parenthesis, negative 1 divided by 2, close it off, hit enter, and I get a negative 6. Let's just do one more. So 12 times a negative 1/2, 3 minus 1 is a 2. So go 12 parenthesis, negative 1 divided by 2, close it off, raise it to the second, hit enter, and I get a 3. Okay, so I can see I'm getting smaller. I can see that I'm dividing by 2, which is multiplying by half. But I also see that my signs are alternating, so that would be a negative 1/2. Okay, you don't have to do any of that stuff that I just did. I feel like I have to offer an explanation. You don't have to do any of it, you guys. The ratio is always going to be right there. Okay, so your formula for a sum of a geometric is S sub n equals a times 1 plus r to the n over 1 minus r. So my a is a 12, my r is a negative 1/2, and my n, can anybody tell me what n is on this problem? It is 6, because I'm finding n is 1 through n is 6. Okay? Okay, so the sum of the first 6 terms is 12 times 1 minus parenthesis negative 1/2, raise it to the 6th power over 1 minus a negative 1/2. Okay, gets a little tricky with all these negatives in that. So guys, go parenthesis around the top, parenthesis around the bottom. Okay? Okay, let's do it. 12, parenthesis, parenthesis, 1 minus parenthesis, negative 1 divided by 2, close it off, raise it to the 6th, close parenthesis, divided by parenthesis, 1 minus parenthesis, negative 1 divided by 2, close it, close it, close it, hit enter, and there it is. Now, I have 7.875, okay? I know that that's an exact number. Yes, it's a decimal, but I still know that it's exact. How do I know that that's exact, you guys? Because it ends, right? So I really think that they would give you that credit, okay? But why not, let's convert it to fraction, and then we know we're going to get it. So everybody just hit second PRB. The answer is 7 7/8, and you're done. Okay? All right. An infinite geometric series, okay? Everybody listen for just a second, okay? I have to explain this to you so that you can understand it. You're pushing your little sister on the swing, and you really push her, and she gets going, okay? And then you stop pushing her. So what happens is she starts going less high, less high, less high, right? But look what happens. Say this swing goes half as high as it used to be, okay? So look right here. Goes really high, and then it goes half as high, and then it goes half as high, and then it goes half as high. Is she ever going to stop swinging? No matter how small of a movement you get, is there always going to be a half of that really small number? Always. So I'm asking you again, is she ever going to stop? She's not going to stop, okay? There's always, no matter how tiny that movement is, you can always cut it in half. It'll just be half. It'll just be even more tiny, okay? That's what an infinite geometric sequence is, okay? So if you look right here, k equals 1 to k equals infinity of a times r to the k minus 1. So if it's infinite, okay, here's your formula right here. Very simple formula to memorize, but it has to converge in order for it to work, okay? So everybody look right here and just kind of listen for a second. This is important that you understand this. Let's say that you have the number 1. And then the 1 goes to a 2. And then it goes to a 4. And then it goes into an 8. And then to a 16. And then to a 34. And then to a 64. And then to a 128. Blah, 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 blah. And they ask you to add those. Okay, this is important, so I want you to listen. They ask you to add those. Well, you guys, the numbers go on forever. So how can you possibly add a sequence of things that keeps going on forever? Okay? Versus this. Look at this. Everybody write down 60. And then 30. And then 15. And then 15 over 2. And then 15 over 4. And then 15 over 8. And then 15 over 16. Blah, 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 blah. Okay? Could you add that sequence? Look at that second sequence. Could you add those together? What if I keep going? What if I go 1,000 terms? Say it again. It'll get so small that when you add that number, it doesn't make a difference anymore. So can you add that together? Yes, you can, because it's getting smaller. This is called converges. Okay, this is what converges looks like. Look, you guys. Oh, that's me. I set an alarm. Okay, does anybody have fluids downstairs? Does anybody have that class? Will you come here for a sec? I have a very... Say it again.
That's all that sound gives me anxiety.
Did it?
Yeah.
I'm sorry.
No, that's what I was just saying.
It's
Yeah, wake up like,
go
oh,
down
my
the stairs. Into the
God.
door, into the food room. It's pushed open. There's an oven right there. Right when you turn, it's facing this way, like I would be facing it. Turn it on 350. That's all you do.
No, but it starts
Isn't that
playing.
weird and random? I've never,
You baking or something?
yeah.
What are you making?
I've never lost my mind the way I did today, and I've never had a student go turn on an oven for me in the middle of class. But hey,
What's
there's a
up with
first.
that?
We're having like a little potluck thing.
Oh, so you cook it here.
I already made it. It just has to bake. Potatoes, like au gratin potatoes kind of thing. Yeah.
Where's this one going?
Okay, so anyway, this is the picture, okay? It looks like this, okay? Starts big and it gets small. The numbers are big at the beginning and small at the end. This one right here, guys, this set, you can't add those. Because if I added like the first 1,000 and I came up with the number, the next biggest number would be really big. And it would make a big difference on my sum. Where this one down here, the next number is so tiny, it doesn't make a big difference at all. Who says I understand the difference? Okay, the picture, this is called diverges, by the way. And the picture for diverges is like this. Starts small, and it gets bigger and bigger and bigger. Okay, something converges if the ratio, what you're multiplying by, is less than 1. Okay, this is really an easy concept, so don't worry. Okay, thank you so much. Okay, example 7. Okay, example 7. The numbers are getting smaller. First you have 2, then you have 1 1/3, then you have 8/9, which is less than 1, blah, blah, blah. So I can look at that, and I know that it is converging. Because the numbers are getting smaller, okay? Here's how you figure out the ratio. You have to know the ratio, okay? A couple of different ways you can do it. This is how I think you should do it. Take the second term, 4/3, and divide it by the previous term, which is a 2. So now I'm going to write that as 4/3 divided by 2, or 2/1, which is 4/3 multiplied by a half. 4 times 1 is 4, 3 times 2 is 6, and 4/6 reduces to 2/3. So I know my ratio is 2/3. That's one way to do it, okay? If you don't, if you can figure it out in your head, you guys, it's totally okay to figure it out in your head, okay? So here's another way to do it. You have to figure out what the ratio is, okay? That's one way to do it. The other way is this. I have a 2/1, and I'm turning it into a 4/3. So what do I multiply by 2 to get a 4? That's a 2. What do I multiply by 1 to get a 3? That would be a 3. Does 2/3, is 4/3 times 2/3 8/9? Well, 4 times 2 is 8. 3 times 3 is 9. It totally works. So I know my ratio is 2/3. Okay? Who says I understand that? Raise your hand. Okay. And then 2/3 is less than 1, so we know it converges. So the formula is the sum of an infinite series is a over 1 minus r. So the sum of this infinite series, by the way, how do I know this is even an infinite series, by the way? Dot, dot, dot. Dot, dot, dot. So it's a, which is 2, over 1 minus 2/3. Put parentheses around the bottom, and let's just stick it right in. Okay, so everybody go 2 divided by parentheses, 1 minus 2 divided by 3, close it off, hit enter. I get an answer of 6, and I'm done. Okay, let's do question B. Okay, look right here. S of n is equal to a 1 minus r to the n over 1 minus r. If you use that formula, you're going to lose everything. Why would I lose everything? That's not the right formula. What formula is it? The infinite. How do we know it's infinite, everybody? Right there. Okay, tells you it's an infinite sum. So that is not your formula. So it's the sum of an infinite series is a over 1 minus r. By the way, someone tell me what my r is. I can't do it if it doesn't converge. I have to make sure it converges. What's my r? It is 1/3. So I would literally write r equals 1/3, and then I would say converges. Okay, so the sum of an infinite series is the first term. Do I know the first term? I don't right now. I'm going to go 1 minus 1/3 on the bottom, put parentheses around it. I can easily find the first term by just putting k equals 1 into that. So I'm going to go a sub 1 is 8 times 1/3 to the 1 minus 1 is 0. 1/3 to the 0 is a 1. 1 times 8 is 8. Okay, grab your calculator. 8 divided by parenthesis, 1 minus 1 divided by 3, close parenthesis, hit enter, and you get 12. So the answer is 12 and you're done. Okay? All right, let's see what we're looking at. Okay, 8 and 9, and then we're done. Okay. A statistician knows a town of population of 3,500 people has a predicted growth rate of 6% per year. What should she predict the population will be in 20 years? Okay, so I have a question for you guys. Is it, first of all, see how this is a percentage right here? If that's a percentage, then you know immediately that it is geometric. Okay, so do they want the formula a sub n equals a times r to the n minus 1? Or s sub n is a times 1 minus r to the n over 1 minus r. Which formula are they asking? Can someone tell me? They want to know what will the population be in 20 years. So think about what this guy means. That guy means take the population the first year, and the second year, and the third year, and the fourth year, all the way up to the 20th year, and add them together. Would that give us the right answer? No, because that means a lot of people would be counted more than once, right? So there's our formula, okay? So they want 20, so it's a sub 20 is the first year, which is 3,500, times the ratio, which I don't know, raised to the 20 minus 1 is 19, okay? Now, let's come over here and let's go a sub 1, a sub 2, a sub 3. Okay, so a sub 1 is 3,500. 6% as a decimal is 0.06. Okay, so let's say our ratio is 0.06. Then you go 3,500 times 0.06 and you get 210. Is that right? That is not right. What does the 210 represent? The additional, right? You can't say plus. You can't do plus on this thing. There's no plus in the formula. So can anybody tell me what I have to do so that when I get that 310, it also incorporates the 3,500, but I can't put a plus in there? Does anybody know? It is, yes. I want you to write this down. If it's increasing, do you see how ours is going up? You have to go 1 point and then the rate. So this would be 1.06. The reason that works is if our ratio was just 1, then it'd be 3,500 times 1. It incorporates that 3,500 into it. The 0.06 is what gives us the increase. So the 1 pulls in the 3,500, the 0.06 gives us the increase, okay? So if you go 3,500 times 1.06, you get 3,710 for the second year, et cetera, et cetera. We could keep going, but we don't need to. So I know that my ratio now is 1.06. So now I can find the 19. So if everybody goes 3,500 parenthesis 1.06, close it off, raise it to the 19th power, hit enter, and you get 10,500, let's round it to the nearest person, 10,590, and that would be people. Okay, question 9. Can I ask you one more favor? I'm so sorry, will you come here? This is so bad.
What? Potatoes.
I know.
Not even like a good
Okay, right on top of that oven, there's a cookie sheet. Put that on the cookie sheet, put it in. You're so nice. I think I'm gonna give you like a treat or something. Say it again. No, because I'll know to go down when the bell rings. Thank you. I know. Something, huh? Anything. Okay. So suppose the motion of an object through a certain medium is such that it travels 90% as far each second as it did the preceding second. If it moves 50 feet the first second. So this is like the little sister on the swing, right? So it goes really high, and then it goes 90% as far, 90% as far, 90% as far. It's never going to stop, because there's always a 90% of something, no matter how tiny the movement is, okay? Okay, so if they give you a percentage, then you know that this is geometric, okay? So I'm going to write down geometric. And then I'm going to write down my two formulas, okay? So it's a sub n equals a times r to the n minus 1, and s sub n equals a times 1 minus r to the n over 1 minus r, okay? So you have to figure out, do I use formula 1 or do I use formula 2? So question A, how far will it travel in the 15th second? Everybody tell me 1 or 2. 1. By the way, let's write in some values. So A and R and N. Okay. So A is how far it goes the first time. That would be 50. Okay. You guys, it's decreasing. Okay. So it's not going to be 1.9. It's just going to be 0.9 because it's getting smaller. It's converging. Okay. And then the N is, I don't know, okay? So we just have to kind of read the question and go from there. So how far will it travel in the 15th second? Well, in this particular problem, part A, our n is a 15, okay? So tell me, again, do I use equation 1 on question A or equation 2? Somebody tell me. Equation 1, it's in a particular second, okay? So it's number 1. Thank you so much. So it's a sub 15 is the first one, which is 50. Times the ratio, which is 0.9, raised to the 15 minus 1, which is 14. So go 50 parenthesis, 0.9, close it off, raise it to the 14th, hit enter, and we're going to round it 3 digits. Okay, so that's going to be 11.438, and that is going to be feet. Okay, how far will it travel? How far will it travel during the first 15 seconds? Tell me which formula, everybody. The second one. So they want from the beginning to the end of the 15th, right? So it's going to be the sum of the first 15 is A, which is the first one, which is 50, times 1 minus the ratio, which is 0.9, raised to the n, which is 15, over 1 minus 0.9. Okay, now I didn't put parentheses around the 0.9 because it's not a fraction. If you want to, you can. I'm not going to because I know I don't need to. And I'm going to add parentheses here and here. Okay, let's put it in together so we make sure we know what we're doing. So go 50, parenthesis, parenthesis, 1 minus 0.9, raise it to the 15th, close it off, divided by parenthesis, 1 minus 0.9, close it off, hit enter, okay, and we get 397 point, now give me 2 seconds, yeah, we're going to round, so let's go 3 digits, so 397.054, and that would be feet, okay. How far will it travel in the nth second? Okay, guys, if you choose the wrong formula, you're not going to get it right. So in the nth second, equation 1 or equation 2? equation 1, okay? And I don't know what n is. So it's going to be a sub n equals a, which is 50, times the ratio, bless you, which is 0.9, raised to the n minus 1. I don't know what n is. There's literally nothing beyond that I can do. Okay? How many seconds will pass before the object travels less than 15 feet? Okay? So 15 feet, that's your a sub n. I'm just going to put it right here. So that's the formula for a specific term. Okay, I want to know when the term is going to be less than 15. So I'm going to do 15. And then I'm actually going to make it an equal sign. Is equal to 50 times 0.9 to the n minus 1. So there's my setup right there. Okay, by the way, guys, it's super important that you know what a setup is. So there was a question, it was on a quiz or a test that you've had recently, and it said to set something up, and a ton of you went all the way to the end. Okay, that's the setup right there. So it's just what's your first step, set it up. Okay, so just be careful. Okay, look at that right now. The second I look at that, I know that there is something that I'm going to have to do, not now, but as I solve, to be able to solve for n. Can anybody see what that is? You're going to have to do a log. Yes. Why are you going to have to do a log? Because the n is stuck up in the exponent, right? So this 50 is not part of my base and my exponent, so I can divide by 50. So everybody go 0.9 raised to the n minus 1 is equal to 15 divided by 50 is 0.3. And now I'm stuck, so I'm going to convert it. So this is going to be log base 0.9 of 0.3 is equal to n minus 1. Then you pull the 1 over, so you have n equals 1 plus log base 0.9 of 0.3. Bless you. Okay, now let's put that in our calculator and let's see what we get. Okay, do you remember how to put log base 0.9 of 0.3 in? I'm going to add the 1 at the end. I'm going to worry about the log first. It doesn't matter. Everybody go log 0.3, close it off, divided by log 0.9, close it off. Then I'm going to add 1 to that, hit enter, and I get 12.427. Okay, how many seconds will pass before it travels less than 15 feet? Is the answer 12 or is the answer 13? Okay, well, it's either going to be 12 or it's going to be 13. Does anybody think they might know? On the 12th second, which is smaller than that, is it going to be less than 15 or is it still going to be more? Still going to be more. So it's going to be 13. Okay, it changes in the middle of the 12th, so it's got to be all the way to 13th. But you know what? It's easy to figure it out, guys. Look right here. If you get confused, just stick it right there. So put in a 12. So everybody go 50 parenthesis 0.9, close it off. 12 minus 1 is 11. Hit enter. 490. Sorry. I think I did something wrong. Oh, yeah. I did something wrong. 50 parenthesis 0.9, close it off, raise it to the, I didn't hear raise it to the, and then it would be, if I put in a 12, that would give me an 11. Is it traveling less than 15 feet? No, I got 15.69. So, but if I put in a 13, then I would go 50 parenthesis 0.9, close it off, raise it to the 12th, hit enter. Now it's less than 15 feet. So if you get confused, just stick those two numbers in and see which one gives you a number that's less than 15. Okay, who says I understand? Raise your hand. Okay, good. Okay, the next one. How far will it travel before coming to rest? What are we talking about? Say it again. It is infinite. So they want to know a little bit more, a little bit more. So they're finding the sum of an infinite. When's it going to stop? Okay, so formula is the sum of an infinite series is a over 1 minus r. I know my r is 0.9. I know my a is 50. I know it converges because my ratio is less than 1. So the sum of the infinite series is A, which is 50, over 1 minus 0.9. Put parentheses around the bottom. Go 50 divided by parentheses, 1 minus 0.9, close it off, hit enter, and the answer is 500 feet. And I'm done. You guys okay?